Good afternoon. So you see, I'm trying to drink, rehydrate, and eat. So I just spent the whole night in Moscow and here. So, with 2 hours of delay in Moscow, 6 hours in the airport. Okay, so it's really a pleasure to be back because I was here, I remember, in February, beginning of February 2011, also for the first event. And also I have a great souvenir because I came at 5 p.m. and it was a big storm, -20 also as usual. And then the professor who took me was stuck. It was a 4-wheel drive and I pushed for half an hour the car to get in out of the snow. So it's a great story. So today we're going to speak about different types of crises. And it's a subject which I think is very important because when you study at school or in textbooks what is the financial market and how it works, we tend to neglect, I think, a very important aspect, which is that financial markets do not behave in a mean reverting way, at least not in a smooth mean reverting way, meaning they are not really attracted to balance, or they do, but in a very abrupt way. So they develop under spells of bubbles and then crashes. So I would like to understand with you how it works. So in order to present the story, I'm going to do the following. Closer? I am, okay. I'm going to discuss, in order to understand the future, because my goal is to try to see, okay, how can we say something about the future? Can we detect future bubbles? Can we analyze when there's a potential instability? First, we need to understand the present. It's clear. And if you don't know the present, if you don't study history, you are bound to repeat the same errors, as we say. So I'm going to try to present what we understand now. In particular, as you know, since 2007-2008, there has been a huge crisis, a so-called Great Recession in the US and the world. And I'll try to understand, and in so, I'm going to explain to you what are the mechanisms for the bubbles. And then I'm going to explain the theory that we have developed in order to predict bubbles, and then I'm going to apply this to analyze through a cockpit the whole world. We are actually right now running with a supercomputer at ETH Zurich, so I'm coming from Switzerland, Zurich, and we have a supercomputer, as in many other universities, which runs every day 25,000 assets, and from this we built a big picture of where are the instabilities potentially developing. So I'm going to present to you the results just last week. Last week. Actually, the latest, I received them very lucky in the airport of Moscow yesterday, this morning. I don't remember now anyway what's the time. So I will show you this. Also for real estate worldwide. Okay, so let's go to the past. Here you see principal component analysis. So it's like a factor, global factor extraction on a series of world assets. You see, for example, here it contains emerging market equity indices, price indices, commodities, metals, energy, currency, and so on. So basically looking at a lot of things, putting this time series one after the other and looking at the first component of this. Just one way of looking at a kind of common factor of what was going on. And what you see, it's an enormous bubble. I mean, in a way you can understand the crisis as in 2007-2008 that started in the US as emerging from a massive growth of valuation all across the board. And of course, this is just a kind of summary view of this, so you can analyze, and I will come back to this, to many examples of this later on. And as you are going to understand through my presentation, this was really like a perpetual machine, an illusion of the possibility to extract money out of the market, out of the real estate market also that was going up. And you can see the crisis as the breakdown here. You see the drop by mid-2008, breakdown of these machines. Another indicator is the famous Case-Shiller index, so it's written here, which is one of the best indices in order to characterize the US real estate market. And you may remember that the crisis basically came from the fact that there has been a peak in this market. So the standard, the standard story until the peak was that for 50 years or more, the real estate market has been going up and up in the US and was a sure thing. It was believed to be certain that it would continue to go up. But no, it started, you see here, it started to plateau in 2006, 2007, and then start to decrease. And when you look at all the analysis by academics, pundits, professionals and so on, they all come to the point that the real estate market stopped growing, it plateaued and then went down, and this is when hell broke. Because if the market has gone up and continues to go up, then even the so-called subprime loans, so meaning the poor household who have been given a loan and who were not really able to pay, would not have been necessarily under by the fact that their house were continuing to increase value for them without them doing anything. So you can look at the epicenter of the crisis by the fact that the real estate market stopped growing. And of course, many analyses have shown that there were many other problems going on together, and we'll come back to this. But in a sense, this illusion in a perpetual money machine, this dancing, this extraordinary growth, was fueled by the real estate market. And the big question that remains unanswered, and you see the answer today, is why did it stop growing? Because this was the epicenter of everything that cascaded into the Great Recession, for example. And I hope you will see the answer by yourself. So this is the little question that we asked at the beginning. So I jump directly to the heart of the question, which is, what is a bubble? So first, on the upper left here, you see something that you know by heart, which is the standard Econ 101 representation of an equilibrium, which exhibits the phenomenon of mean reversal of negative feedback, where the larger the price, the lower the demand. And the larger the price, the larger the supply. So in the end, you have an equilibrium when this crosses that fixes the equilibrium price and the equilibrium quantity of whatever product you think are at this in a supply-demand market. So this is negative feedback, because if you have an increase in price, then the demand will decrease, so therefore there is a force, if you like, to push the price down, right? Because there is less demand. So this is, of course, negative feedback, negative process that tends to bring the price down. Now, here on the right, you see a kind of cartoon depicting what can happen when a positive feedback process occurs. And this is represented by the lower arrow here, where you have a case where, surprisingly, shockingly, the higher the price, the higher the demand. Yeah? So, it looks stupid, a priori, right? The more the price increases, the more people will be attracted to buy the product. Doesn't make sense from a standard economic point of view. But there are many cases, and it's always the case during bubbles, that this happens. And when this happens, you see there's a problem to finding an equilibrium. So either you have no intersection, or if I put this curve up there might be a crossing, but it's very easy to check that this fixed point is unstable. While here, the fixed point is stable. There is mean reversal. So here we are in a positive feedback. The larger the price, the larger the demand, and you have an unstable situation where the price cannot converge, but that it tends to build on itself and grow until an instability occurs. Now, positive feedback, so I took an example of a bubble to show really the intuition behind positive feedback, and we find it in many different phenomena. For example, this is just a droplet. When you wash your hand under a tap, you have a droplet which is dripping, and you have this process where, positive feedback also, process where there's a neck. Now, you know, this is called a surface tension. This creates a force that holds the mass of the droplet. But the mass is roughly fixed because this is very small compared to the total volume. But for the smaller the neck, for the same weight, the larger the force per unit surface, the larger the stress. The larger the stress, the larger the flow. The larger the flow, the faster the thinning. The faster the thinning, the smaller the area. The smaller the area, the larger the stress on the remaining area. The larger the stress on the remaining area, the larger the flow. The larger the flow, the faster the thinning, and so positive feedback, which gives rise to a finite, what in mathematics we call a finite time singularity. And a finite time singularity actually is the solution of these hydrodynamic equations of the flow in the neck that makes the neck go to zero in finite time. A finite time singularity. Actually, what I'm going to do now is to explain how a finite time singularity occurs in finance. And this is absolutely fundamental to understand. Okay, I can write on the board. Okay. Let me just, can I? Do you have a blackboard? So you have a pen? Yes. Opa. So, if I can write here, just want to make it clear. Yeah, you have this. So it's okay. So, if I look at, and you have something to wash, or should I take something like this? Okay. So if I look at the trajectory of a price, dp dt equals Rp. So this is the first term of proportional growth of the standard model in finance, where you would have usually, so you would write dp equals Rp dt plus sigma p dw, which is the standard Black-Scholes model of a stochastic process, the simplest thing. I just look at the deterministic component. So this is the solution of this equation is what? Very simple, right? It's P equal P0 exponential RT. This is the power of compounding interest. The price goes exponentially with a constant rate of return. Yeah? But now suppose that the return is a function of the price. There's positive feedback. The larger the price, the larger the demand. The larger the demand, the larger the push on the price, the larger the rate of return. So assume I capture this by saying that the rate of return grows proportional, let's say, like alpha p itself. Just for the sake of discussion to capture the idea. So then the solution, so the equation becomes dp dt equals alpha p squared. Yes, so alpha is a constant. Now, what is the solution of this equation? Simple and very easy to integrate. You obtain P equals some constant divided by Tc minus T to the power 1. Actually, if you were putting an exponent delta here, you will have delta positive, delta plus 1, and you will obtain an exponent 1 over delta. So, you have a finite time singularity. The exponential is transformed into a trajectory, which you see it's a hyperbolic behavior. So if I draw what is happening, you have the price like this. Tc is a critical time, and the price goes very slowly usually under this, which is to be contrasted with what would happen when you have a pure proportional growth, constant growth rate, where you start from here and it grows exponentially forever at the constant growth rate. So as soon as you put positive feedback, then you have the creation of solutions of the equations which are monsters. They blow up in finite time. It could be price going to infinity, it could be some other moment, some other characteristic, some other variable. The main point as an economist is very shocking, because this kind of equations give rise to solutions that do not exist at all times. And this is, by the way, one reason why this type of models have been very little studied because many of you mathematicians, I understand, doing finance and so on. The first condition that healthy economist does when we create a model is to impose or to check existence of solution. And what is the meaning of existence of solution? Is that the solution exists forever. So by construction, there's an enormous class of dynamical equations, mathematical equations that are thrown away, and for me it's like throwing the baby with the bath, because this class of solutions are, and I'm going to show you, argue very strongly, with a lot of slides, a lot of data, are actually describing the real world. Now the point that the solution blows up in finite time doesn't mean that the universe explodes in a big bang, or that life stops. It just means that the solution stops describing what is happening and just tells you there's a change of regime. Something happens differently, and the mechanism, the dynamics, is different afterwards. And it's very clear. If I'm now thinking about a bubble, there will be a crash, maybe, something. Policymakers are going to intervene. Regulators are going to change the rules and so on. So indeed, it is a regime. So it's like in phase transition in physics, where indeed we cannot extrapolate when we are in a liquid phase, when suddenly you have ebullition, it becomes a gas. It's a totally different regime that cannot be described by the same effective equation. Okay, so positive feedbacks. Do they really exist? So this is a list. I'm not going to, I don't have time to do it, to discuss in details, but you can do it yourself. This is my list of all the positive feedback that I've been able to find, which are present in finance and in economics. And I characterize them in two classes. The first one I call technical rational, and the second one is more behavioral. So having to do with humans. Let's say humans who are not fully rational, who have imitative habits. But look just at the first. I will just comment on one or two. Option hedging. Most of you know what is an option, call option, or put options. Now, if I am a bank and I sell you a call option, I want not to have a naked situation like this, so what I'm going is I'm going to cover, to hedge my position by buying a little bit of the underlying stock, underlying the option. Now, in the very definition, the very process of pricing by Black-Scholes the value of this call, I need, as a bank, to buy more of the underlying asset in order to cover and to hedge correctly my call, if the price has been going up. Positive feedback. The price is going up, I have to buy more of it. I demand more of the underlying just to cover the risk that I have. So the intrinsic risk neutral, so it's the pricing of the options of Black-Scholes, which was a great revolution that gave a Nobel Prize in 1997 to Scholes and Merton, is based on the idea that you can eliminate completely the risk by replicating completely the cash flow of the option by a reproducing or replicating portfolio, has intrinsically a positive feedback process in it, which is neglected in the standard theory because we don't take into account the impact of this replicating strategy, which is there. So Papanicolaou, for example, a mathematician at Stanford, has introduced in a paper in 1998 this effect that indeed the more the price goes up, the more you have to buy in order to hedge. And then you can find that the positive feedback gives several things. He has a quite restricted setup. It increases the volatility. The volatility is actually influenced by the strategy itself and gives excess volatility. That's one thing. Insurance portfolio strategy is very famous. Leland Rubinstein, in the 1980s, they developed so-called synthetic puts, and 1/3 of the whole US investment markets were using these instruments. And the strategy is very simple. When the market goes down, and there are several levels, you have to sell. The markets go down, you sell. Positive feedback. Yes, because you push even further the price down. It's positive feedback towards the spiral down. And so on and so forth. I'm not going to discuss, but The main point I want to stress here for you is to attract your attention to the fact that, contrary to what you learn at school, the market is very strongly influenced by positive feedback processes and not just negative feedbacks or what we call mean reversal. So these processes are active all the time, everywhere, and they sometimes combine in order to give transient lift bubbles, sometimes of very large proportion. So I think there is a kind of blindness in not recognizing the importance of the positive feedback in describing financial markets. And of course, I should not also underweight the behavioral aspect, which is the fact that indeed people are not purely rational animals of economic theory. They tend to imitate, in particular. They tend to herd, and I will come back to this a bit more. Now, since I started with this principal component analysis of the massive balance, this is my list. Actually, when we compiled hundreds of papers, we have analyzed the cause of the crisis of 2008. This is essentially the bullet points, or the title, if you like, of the main mechanisms that have, each of them, or in combination to Baidu and so on, been analyzed to try to understand where did the crisis come from. And you have papers who say, oh, this was due to government-sponsored entities. That was a big problem. And some said, it was the lowering of the lending standard, or it was the rating agency failure, or it was this. They were all present, all. And they were all giving positive feedback. Because as the lowering of standard goes down, it's much more easy, for example, much easier to get access to credit. More credit means more money to invest, pushing the price up. As the stocks of value of your collateral increase, you can even get more credit, positive feedback, the demand increase, and the price increase even more. All over the place. So indeed, positive feedback was really prevalent as in many, many different dimensions, as you see. Now, positive feedback gives rise, when you have multiple agents, to cooperative effect. So that's another aspect, which I illustrate here with the problem of the clapping of hands in a theater. You maybe have all experienced this situation when, after a nice opera piece, people start to clap. The clapping is first incoherent, noisy, but as it goes on, it starts to synchronize automatically, right? And this is actually reproduced in laboratory. It has been published in Nature, actually. This was really studied in detail in all dimensions. And this is actually a phenomenon of positive feedback from the sound of others to your ears, which are then analyzed by your cognitive processing, going back to the motor control, and then you spontaneously, without thinking about it, synchronize. So synchronization is a collective phenomenon. A collective phenomenon is very important in markets. If everybody is synchronized to sell, what does it give? A crash, right? If everybody is synchronized to buy, it gives a bubble. So we are going to use this type of concept in order to understand the financial bubble and crashes. So this is a cartoon to show one of the dimensions of imitations, by imitation. But actually, this cartoon is very famous. It tends to imply that the participants are a bit stupid and just imitate stupidly like this. But actually, this is not true. A lot of research in psychology, for example, demonstrate that imitation, which is one of the processes behind positive feedback, is practiced by us and a few of the most intelligent animals in the world, like some birds, which are very intelligent, primates, and so on. And all along our life, from the baby stage, we learn by imitation. So it's an extraordinary process of learning. There's also the concept of information cascades, where you are somehow forced to imitate by the weight of the social group. You have also this nice experimental result or empirical result published in Journal of Finance, which demonstrated that in our global village, mutual fund managers tend to overweight the same stocks if they belong to the same city or the same geographical area. which is very surprising in a way, but it shows the power of cocktail parties, of going to the same place, exchange, and the influence by proximity. And biological research, neurobiology in particular, has demonstrated, and more proof are accumulating, showing that we probably are hardwired in our brain to be even over-imitative. So we tend to really overdo it, and probably it was evolutionary advantages when we were hunter-gatherers 50 or 100,000 years ago, and now it is maybe backfiring in the modern world. So all those together helps us to construct the following picture of a bubble. I start with this Stammer scenario, which summarizes hundreds of bubbles that we have studied and others, where a bubble starts with a new story, a new opportunity, a recovery from a previous recession. For example, like the internet new economy story. You start to see maybe a potential new technology and so on. I was yesterday at Credit Suisse in Geneva, and there was a big number of investors, and there it was interesting. The Credit Suisse advisors were trying to say, oh, they wouldn't say the next bubble, of course, they were saying the next investment opportunity is robotics. Robotics is, robots everywhere. And this is going to solve the aging problem in Japan, in Germany, maybe in Russia, and so on. So you are going to replace people and so on. So you have a story. The story gives rise to some investment, some position on the market. The market is pushed up. There are some positive results in the economy. The credit becomes smoother. The banks buy the story. They give access to credit. Positive feedback. And this slowly takes off on itself with all the sign constructing finally an euphoria, close to the peak. But this is not sustainable. And the main point I want really, that's why I took the trouble to derive this, and I will try because you may not see that from the other side, but maybe I should carry it. Can you see on this side? Yeah? Okay. No? Yeah. So the main point is that when you have positive feedback, the process is not sustainable. Yeah. So the process is not sustainable. So it has to stop. It has to stop somewhere. And by the way, mathematics said it's a finite time singularity. It's called also a movable singularity, because you have out of nowhere, it is not written in the equation where the TC is coming from. And so the TC is movable. It's movable simply because it is encoded not only by the parameters delta and alpha, but also by the initial condition. So actually, and you'll see, the trick is then to read the trajectory to try to infer TC. The end of this exuberant phase. And of course, there's a revolution. And during the development of bubble, this is a graph that I borrowed from Kindleberger, who has a famous book, who has documented about 30 bubbles, cases, famous bubbles in history. You have the following dynamics of money, where smart money comes in, so sophisticated investors, informed investors. Then you have less smart money, like institutional investors, then the public, and then, let's say, my grandmother, who takes the money out of the cash out of the mattress to not being able to resist the attraction of the game. And of course, then, the system becomes unsustainable. So what I want really to impress in you is the fact that when you have positive feedback, even if things are so beautiful, so great, we are making so much money, it is intrinsically unsustainable. And so the question why it crashed is very clear. It's because it's going too fast and it's indeed ingrained in the dynamics.